Hello students, this is a video on the topic test that we have at Bodhee Prep for you. These tests are designed to help you evaluate your test readiness. So these topic tests should be done only after you've gone through the basic concepts of a topic and practiced those questions. And then you take this test to understand whether you're able to apply those concepts in a timed manner and test or not. Once you've given the test, that is when you go through this video. The video talks about the basic analysis of the test and the questions per se. And if you do like the test and find them useful, there are more than 200 topic tests available on the Bodhee Prep Android app. The link for the app is in the description. Just download the app and make use of the tests. This video specifically is about the topic remainders, and this is test number 2 that we're discussing in this video. Overall, the test was easy to moderate level of difficulty with about 7 questions, net correct, giving you a 95 plus percentile in the CAT scenario out of 10. And attempt time for this test would be somewhere around 20 odd minutes, assuming that we're doing all the questions and not just the 7 questions that we want to get correct. In the end, we'll also talk about which questions should have been attempted. First, just let us go through the questions quickly. Question 1 says, find the remainder when 39 factorial is divided by 41. So again, a direct application of the Wilson's theorem. Wilson's theorem says uh, n minus 1 factorial divided by n has a remainder of n minus 1, where n is prime. From here, we can say n minus 1 factorial is nothing but n minus 2 factorial into n minus 1. So if we are getting an overall remainder of n minus 1, where n minus 1 is the last number itself, so from the remaining part, the remainder has to be 1. And therefore, an extension to Wilson's theorem is n minus 2 factorial upon n has a remainder of 1 when n is prime. That is applicable here, 39 factorial upon 41. Since 41 is prime, so 41 minus 2 factorial will simply give us a remainder of 1. Direct application of a theorem, and therefore I'm saying easy question. Should you look at the question, it should be over technically, but a minute and a half good enough to answer the question, to just to locate where this question is from. What is the least rational number that will leave a non-zero remainder when it divides 25 factorial? So we are dividing 25 factorial by a number and we want a remainder. So division should not happen. Now 25 factorial is nothing but 1 into 2 into 3 into 4 into 5 and so on, up till 25. So obviously no number from 1 to 25 will not divide 25. All of these numbers will divide 25. If we look beyond 25, 26. Now 26 is 2 into 13. Both these numbers are present here. So if I write 25 factorial upon 26, we can divide by 2 and 13. So the remainder will go away. We will still have terms in the numerator, so division is possible. If we look at 27, again 3 and 9 are there. 9 3s are 27, so division will happen. 28, again 14 and 2 are both present in this range. 14 2s are 28, division will happen. 29. 29 is the first prime number after 25 factorial. If we divide 25 factorial by 29, there is no number in the range 1 to 25 that divides 29. And therefore, this division will not happen. Hence, the answer that required will be 29, the least natural number which will not divide 25 factorial. Again, it's a basic concept, and the answer is not very complicated. Just looking at 2 or 3 steps, and therefore I'm saying 1.5 minutes. Overall level of difficulty easy. What is the remainder on 1 factorial plus 2 factorial plus 3 factorial and so on till 207 factorials divided by 15? 1 factorial problem, 2 factorial problem, 3 factorial problem, 4 factorial problem. Beyond this point, when we talk of 5 factorial is nothing but 1 into 2 into 3 into 4 into 5. As we can see, this is divisible by 15. And any number thereafter, because 6 factorial is nothing but 5 factorial into 6. 5 factorial is divisible by 15, therefore 6 factorial is also divisible by 15. So every number, including 5 factorial and anything after this, is divisible by 15, so no remainder. The only remainders will be from this part. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 24. So this gives us 33 divided by 15, remainder 3, option D becomes the answer. Basic question, 90 odd seconds should be good enough to get this question correct, provided we understand the concept of factorial and the fact that 5 factorial includes 15. Beyond that, every number has 15 in its product or in its value. What is the remainder when 2 raised to power 99 is divided by 33? A power of 2 close to 33 is 32, which is fifth power. 2 raised to power 99, obviously we cannot take out 2 raised to power 5. So multiple of 5 less than 99 is 95. So we write just 2 raised to power 4 into 2 raised to power 95. This can be written as 2 raised to power 4 into 2 raised to power 5 raised to power 19. 95 is 5 into 19. It becomes 2 raised to power 4, 16. 25, 2 raised to power 5 is 32 raised to power 19. And 32 is nothing but 33 minus 1 raised to power 19. As we can see, 33 is divisible by 33. Therefore, the remainder from this part will be minus 1 raised to power 19. And 16 is not divisible by 33, so 16 stands as it is. Minus 1 raised to power 19 is minus 1. Therefore, the overall remainder will be minus 16. Since the remainder is negative, to get positive remainder, we just add it to the divisor. And therefore, the positive remainder will be 33 minus 16, which is 17, becomes the answer. Again, it's a moderate question because there are a couple of steps involved here. But the concept is not something new. If you've done remainders, you're expected to be able to do this at least. 2.5 minutes, good enough to answer the question. Find the remainder when 21 raised to power 31 plus 37 raised to power 31 is divided by 29. A trigger for this question always is a raised to power n plus b raised to power n. Power is same. Is divisible by a plus b when n is odd. Therefore, we can say 21 raised to power 31 plus 37 raised to power 31 is divisible by 21 plus 37, which is 58. 58 is nothing but 29 into 2. So since the number is divisible by 58, it will be divisible by 29 as well. Hence remainder 0. Easy questions. 1 minute is good enough to answer this question because a standard form of a question that you would have done during practice. What is the remainder when 4 raised to power 96 is divided by 4 raised to power 96 divided by 6? Now 4 divided by 6 gives a remainder of 1. 4 square 16 divided by 6 remainder of 4, sorry. 4 square 16 divided by 6 gives a remainder of 4. 4 cube 64 divided by 6 gives a remainder of 4 and so on. Any power of 4 gives a remainder of 4 when divided by 6. So this is my answer. And that's it. That's a pretty much an easy question. Minute good enough to answer the question. If you want to actually solve it as well and we don't know this point, then how do we go about solving this question? 4. 4 raised to power 96 divided by 6 can be written as 2 raised to power 192 divided by 6. 2 square. 2 square is 4 and 2 into 96 is 192. Divide by 2 on both sides. Since we are dividing by 2, we will again multiply by 2 for the answer. This becomes 2 raised to power 191 by 3. 2 raised to power 191 is nothing but 3 minus 1 raised to power 191 by 3. So the remainder will be minus 1 or 3 minus 1, which is 2. Since we had divided by 2 to reach here, so to go back to the normal question, we will multiply the remainder by 2 as well. And the overall remainder will be 4. But again, I'm just using the pattern that any power of 4 divided by 6 gives a remainder of 4, and therefore a minute and a half to get the question done. What is the remainder when n raised to power 7 minus n is divided by 42? N is positive. What we can do is just put n is equal to 2. That becomes 2 raised to power 7 minus 2. 126 by 42. This is divisible. And therefore remainder 0. So 0 is my answer. But if I have to solve n raised to power 7 minus n, take n common, n raised to power 6 minus 1. This can be written as n cube square minus 1 square. This becomes n cube minus 1 into n cube plus 1. N cube minus 1 will be n minus 1 into n square plus n plus 1. N cube plus n square minus n square plus n minus n minus 1. And n cube plus 1 will be n plus 1 into n square minus n plus 1. N cube minus n minus n square plus n square minus n plus n plus 1. This can be rearranged as n minus 1 into n plus 1. These are three consecutive numbers, n square plus n plus 1 and n square minus n plus 1. Three consecutive numbers will always be a multiple of 6. 1, 2, 3, 2, 3, 4, 3, 4, 5, 4, 5, 6, and so on. And one of these will always be a multiple of 7 or vice versa. What we can do is we can put n as 1, 2, 3, 4, 5, 6, 7 and check. Because if it happens for the 7 numbers, it will happen again because divisibility by 42 is nothing but divisibility by 6 and 7. If a number is divisible by both 6 and 7, it will be divisible by 42. So if we check for all of these values of n, we would have checked for all the 7 values. Clearly, n cannot be 1. This will become 0. So we start from 2. If we put n as 2, this becomes 1 into 2 into 3. 4 plus 5, 6, 7 into 4 plus 5 minus 1. 4 plus 1, 5 minus 3. Clearly, 7 into 6, 42 is there. If you put 3, we'll get 2 into 3 into 4. We'll get a 6 there. 3 3 is a 9 plus 3. 12 plus 1, 14. Again, which is divisible by 7. I'm not writing the entire thing, just looking at 6 and 7s now. If we have 4, we get 3 into 4 into 5. And 4 was 16 plus 4, 20 and 1, 21. Again, this is a multiple of 7. We already have a 6 in the front. If we have n5, we'll get 4, 5, 6. We already have a 6. 5 has a 25 plus 5. 9, 13. 5, 5 to 25, 30, 31. 5, 25 minus 5, 20 plus 1, 21. I think we made a mistake here. 3 square is 9, 9 plus 3, 12 plus 1 is 13. 3 square is 9, 9 minus 3, 6 plus 1 is 7. Now it is okay. This is the value for 3, this is the value for 4, 5. For 6, again for 6 we don't have to worry because now in the consecutive numbers we'll have 5, 6, 7. So both 6 and 7 are already there. Similarly for 7 we don't have to worry, we'll have 6, 7, 8. So both 6 and 7 are there. So the point being, we'll always find a 7 somewhere in the term, and since there are 3 consecutive numbers, there will always be a 6. So this number will always be divisible by 6 and 7 both, hence always divisible by 42. So the remainder will always be 0. Again, I think a moderate level of difficulty question should be able to solve it in 2.5 minutes. But as I said initially, just put n as 2. Since there is a definitive answer, it has to be the answer for each case. So just put n as 2, get the value of 0, and that is the end of the question. What is the remainder when 2 raised to power 96 is divided by 96? 2 raised to power 96 is divided by 96. We can use the Euler-Thorsten method, but okay. I am dividing this by 96. 16 and 32 into 3. I am dividing this by 32. Whatever answer I get after this step, I'll multiply it by 32. The 32 is 2 raised to power 5 essentially. So here we'll get 2 raised to power 96 minus 5, 91 upon 32, 3 is 36. This is nothing but 3 minus 1 raised to power 91 divided by 3. So remainder of minus 1 raised to power 91, which means a positive remainder of 3 minus 1, which is 2. Since this was divided by 32, the original answer will be multiplied by 32. Hence the answer is 32 into 2, which is 64 becomes the answer. Again, easy question, I'd say. Not more than 2 minutes to solve the question. What is the remainder when 3 raised to power 444 plus 4 raised to power 333 is divided by 5? First, let us look at 3 raised to power 444. Now, power of 3 close to a multiple of 5. 3, 9, 9 can be done. So we can write this as 3 square raised to power 222 divided by 5. So 9 raised to power 222 divided by 5. 9 is equal to 10 minus 1 raised to power 222 divided by 5. The remainder will be minus 1 raised to power 222, which is nothing but 1. So for this, the remainder is 1. For 4, 4 raised to power 333. 4 can directly be written as 5 minus 1 raised to power 333, which will give us a remainder of minus 1 raised to power 333 or minus 1. So the overall remainder will be 1 minus 1, which is 0 becomes the answer. Again, a relatively easy question. Because there are two steps, you might call it moderate. Attempt time 2.5 minutes should be more than enough to answer the question. A two-digit number is divided by the sum of its digits. What is the maximum possible remainder? Now, for a two-digit number, of the form 10a plus b, the sum of digits being a plus b, the maximum sum of digits possible is 18. If we take a plus b as 18, the only possible number is 99. And 99 divided by 18 will give us a remainder of 9. So what I'm doing is I'm starting from the maximum divisor possible. And for each case, look at the remainder. Because for high divisors, the cases will also be fewer. This is one case that we're getting. Second, suppose a plus b is 17. The number here, 17 means has to be 9 and 8. The number could be 89, the number could be 98. If we divide this by 17, 89 by 17 will give us a remainder of 34, 68, 85. 7 into 5 is 85. So this will give us a remainder of 4. 98 divided by 17 will give us a remainder of 85 minus 13 is 85 minus and 13. This is the highest so far. If you look at a plus b being 16. Now, if the sum of digits is 16, the number could be 16. 6 and 10 is 79, 88 or 97. Dividing 79, 16. 16, 4s are 16, remainder would be 15 here. 88 divided by 16, the remainder would be 80. Remainder would be 8. 9, 24, 8. Yes. And finally, 97. 97 divided by 16. 9, 17. The remainder would be 1. As we can see, the largest remainder possible is 15 when the number is 79. And it is divided by the sum of its digits, because for all other numbers, the sum of digits will be less than equal to 15. And therefore, the remainder, when we divide something by 15, has to be less than 15. So, for no other case can the remainder go up to 15. And what is the maximum possible remainder? 15 becomes my answer. When 79 is divided by the sum of its digits, that is when we get the maximum possible answer as 15. Again, I would say this was probably a high level of difficulty question, because the starting point may not be very clear, and chances are we start making equations, which makes it even more complicated. That's a difficult question. Once you've cracked it, maybe 2.5, 3 minutes, good enough to answer the question. So overall, if you look at the test, as I was saying, easy to moderate level of difficulty paper, 7 questions net correct should happen in about 20 minutes. If I had to choose my 7 easiest questions, they would be 1, 2, 3, 4, 5, 6, and 8. Which are these questions? Definitely doing this direct application of Wilson's. Again, doing this as well. Just had to calculate 29. Have done this question earlier, so would have attempted this. Again, would have done this question as well. Just taking 2 up to 32 was all that was needed. Direct application of formula, no calculation required. This is a pattern that I've seen earlier, therefore would have attempted it. This, I think, was a good question in the sense that, fine, you put the value of n as 2, you get the answer. But otherwise, if I had to solve this, I would not have solved it in the exam. This probably I would have done rather 8 or 9, you can take a call. 8 had some steps. 10 is something that I would not have attempted in the exam. Yes, because there is a very good chance of missing out. The starting point is very difficult. So 1, 2, 3, 4, 5, 6, 8, and 10. 8 and 9 you can take a call amongst one of the questions, this or that. But yes, if I had to choose, these would be my 7 easy questions to attempt in the exam.